Hello.
Hello, everyone.
Yeah.
Good afternoon. Dear authors and invited guests, welcome to the technical session 3E. Myself, Anjali, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation, it is my great pleasure to welcome you to the International Congress on Information and Communication Technology, ICICT 2023, London, United Kingdom. The 8th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th February and 21st February 2023. And the virtual event will be held through Zoom today and tomorrow, that is 22nd and 23rd February 2023. I hope you will enjoy the knowledgeable and interactive sessions to the day. And in this session, we have 6 presentations, and each presentation will be given 12 minutes for the presentation, and then 3 minutes for the question and answers round. On 10 minutes, I'll raise a gentle reminder for all of you to conclude your meeting. There is another request to all the participants that you all please stay connected with us till the closing remarks. Also, if you have any query or any doubt, you can write it to me in the chat box. Just before we get started, I would like to introduce you all to our session chair. We have our session chair, Professor James Stephen Mika here. Professor James Stephen Mika is a full-time professor, Dr. B.R. Ambedkar Chair at Andhra University, and is also serving as Dean, Transdisciplinary Research Hub, Andhra University. He has been in teaching and research for over 20 years. He served as a principal and professor of CSE at VISTM Engineering College, Visakhapatnam, over 9 years. He also served as an executive council member of Andhra University and serves on various institution boards. Professor James also acts as a mentor of American Corner, Visakhapatnam, Andhra Pradesh. He is an expert in amalgamating technology with social needs to provide novel solutions. We are grateful to have you here, sir. Thank you for your presence.
Thank you, Anjali.
Okay, so we would like to begin our presentations. So I would like to request our first presenter, Robert Zimmerman, to please present their paper on implication of 3D printing on physical distribution in logistics and supply chain management. Dear presenter, please present your paper.
Hello, everyone.
Hello.
Hello from Austria.
Great to see you.
So let me share my screen first.
Yeah.
Okay. Yes, can you see my screen?
Yes, of course.
Wonderful. Okay, yeah, then let's say we start. And yeah, a warm welcome from my side. As I said, my name is Robert Zimmermann. Also on behalf of my co-authors, Patrick Bandner and Jessica Almendinger, I want to welcome you to this presentation called Implication of 3D Printing on Physical Distribution in Logistics and Supply Chain Management. Some words about me. Yeah, I'm from the University of Applied Science, Upper Austria. I'm doing research in the area of digital retail and retail logistics. And if you have any questions regarding this presentation or regarding the paper which we have written, then please contact me under the address here. So robert.zimmermann@fh-steyr.at. And I'll be happy to answer your questions, or yeah, whatever you have, just send it to me. Without further ado, I would say we start with today's presentation, which is again implications of 3D printing on physical distribution in logistics and supply chain management. And we can say that 3D printing is a technology that is predicted to have a huge impact in logistics and supply chain management. And that becomes especially obvious when you look in the literature and you find the typical application scenarios of 3D printing, which are smart manufacturing processes, spare part management, or last mile distribution. And looking at these specific application scenarios, we see that an area heavily impacted by 3D printing will be the physical distribution of goods in the logistics and supply chain management networks. And we took this and digged a bit deeper into the literature and found that, however, research on benefits and application in practice is still very scarce and thus must be elaborated from a practical point of view. And therefore, we formulated the aim of our paper to be to elaborate recent use cases and effects of 3D printing in the area of physical distribution logistics and supply chain management. And for this, we formulated 3 research questions, which we wanted to solve. Research question number 1 was, how does 3D printing affect the processes of and the strategic approach to distribution logistics? Research question number 2 was, how does 3D printing influence the role of logistic service providers involved in the distribution processes? And research question number 3 was, how does 3D printing affect the processes of warehousing, picking, and transport? How did we actually tackle those research questions? So coming to our method, as our topic is subjective, complex, and quantitative data is barely available for this topic, we used semi-structured expert interviews because they were well suited to collect insights regarding specific domain knowledge, which is difficult to uncover with survey-based methods only. And we used an openly available platform called Wer liefert was, or in English, that would be Who Delivers What. And we used this platform to identify experts with specific domain knowledge in the area of 3D printing. So we set this to our criteria. We want only to contact experts who have experience in 3D printing and 3D printing processes. And with that, we found 9 experts which were actually willing to talk with us and to have the interviews. And for these expert interviews, we then used cross-interview comparison to identify commonalities and differences between the differing expert opinions. Just to give you an overview from which knowledge areas these experts come from, I have this table for you. And we see that we have experts from small, medium, and large companies. So we have companies with around 12,500 employees with 2.5 billion euros of turnover, but we also have companies with only 10 employees, which only make like 2 million euros of revenue. And we see that their expertise also is quite broad. So we see that on the one hand, we have the actual producers of 3D printing machines, prototypes of these machines. We also have companies which just use 3D printing technologies. So for example, this is the company number 1, they just use 3D printers. And also we have a company who actually does 3D metal printing. So one is plastic, the other one is metal. So you see our expert selection is quite broad in this regard. And yeah, let's check out what our experts actually said to the questions we asked them. So coming again to our first research question, how does 3D printing affect the processes of and the strategic approach to distribution logistics? Here our experts separated this into centralized distribution scenarios and decentralized distribution scenarios. And for centralized distribution scenarios, expert mentioned that there will be regional 3D printing facilities, and for the decentralized, there will either be local, private, or mobile distribution scenarios. And I would say we go a bit more into detail into those. So starting with the centralized distribution scenarios, here the experts said that these will have the highest quality, but however will also be very expensive to realize, wherefore, which is why they need a lot of machinery and a lot of know-how needs to be put into these 3D printing facilities. And therefore, they are only suitable for large companies, because obviously this is only an operation a large company can afford. However, they should be placed in junction areas. So not locally, but in junction areas. This would mean that local delivery would still be necessary, even though having these regional 3D printing facilities. So this for the centralized distribution. So what were decentralized distribution scenarios the experts could imagine? So first of all, here we have the local distribution scenario. This is the picture on the left. And you can imagine this a bit like a copy shop, but for with 3D printers instead of copying machines. So this would be rather suitable for small and independent companies. However, currently the profit margin is expected to currently be low, as the equipment is still quite expensive. And as I said before, skilled workers are actually needed to operate these 3D printers. And also the experts here pointed out that these so-called CAD data, so this is the data format which is used to share the 3D printing files around the world, that can actually be quite problematic, as obviously it has some opportunities. You can share them quite easily throughout the world because you just send a file. However, imagine you are a huge company and you send a specific spare parts CAD file to such a print shop. And then what happens afterwards, after your job is finished. Maybe this specific parts get shared around the world, but you don't want it. So there are a lot of open questions regarding these local distribution centers, regarding data security also. However, what the experts also pointed out, that especially these local distribution centers can reduce the costs for spare parts in remote locations where especially the last mile delivery would be quite expensive. And that would obviously get cheaper if you would just print the specific part you need right on the spot. Then for the private distribution scenario, this you can imagine like every one of us having a private 3D printer at home. The thing with that is, although 3D printer prices drop, the complexity of these 3D printers does not. So that would mean that this is not feasible for complex parts. Maybe it is easy to print little miniatures or so that can be realized at home, but just imagine you want to print a very necessary spare part, and then you want to be sure that this spare parts reaches some requirements. You know, it must be sturdy, it must have the right material, it must hold up a certain amount of pressure or whatever. And this can be quite hard to achieve in a private setting, which is why this is not feasible for complex parts. However, the experts also point out if somewhen it would be possible to print everything at home, obviously that would eliminate all costs of transportation, as you could just print everything at home. And last but not least, as a decentralized distribution scenario, there was the mobile distribution scenario mentioned. However, this seems to be unrealistic on the large scale. So with mobile distribution scenarios, we mean scenarios where you just pack all the 3D printing in like a container you see below, and then you just ship it to the location where you need it most. But this seems to be unrealistic on the large scale, as 3D printing is very fragile, which is why that might be difficult. But on a small scale, that should still work. So much for research question number 1. Coming to research question number 2, how does 3D printing influence the role of logistics service providers involved in distribution processes? Here, generally, they are seen a huge potential in 3D print centers or service pools as new business opportunities. For example, here on the left, you see, which was also mentioned by our experts, the idea of DHL, who plan so-called print shops or service pools. And in these print shops, this would just be something like the print shop mentioned before, but handled by a larger company and also connected to a warehouse. And also, so here you combine the print shop and the distribution center kind of. So that means you have a large warehouse where a specific order is just printed for you, and then you can either ship it via last mile to where it's needed, or you just just pick it up at the store right away. And obviously, this would then require less warehouse space, as everything can be printed on demand. However, this can also be a huge threat, as it would eliminate multiple steps along the supply chain. But however, the distribution still remains local, but the global distribution would be reduced. And therefore, for especially service providers who doing global shipment, that would reduce kind of their business area, which might also be a threat, which has to be taken into consideration. Okay, coming to the last research question number 3, how does 3D printing affect the processes of warehousing, picking, and transport? Here again, this is such kind of 3D printing warehouse from the inside. And here we see for warehousing, as I said before, it remains important, but becomes less necessary. So obviously you still need to stock on things, but the overall stock level will decrease, as you can just print what you need just in time, or just when it's required, let's say. For transportations, as I said before, the routes will shift from global to local. You don't need to ship all the materials around the world. You just need to ship it to the specific customer from where this warehouse wherever stands. And so as I said, regional distribution centers become less important, but local distribution centers become more important. And the experts also say here that there are great time savings anticipated, as you don't have to ship it all around the world, but you can just print it where it is. And and as I said, so there will be less volume will be shipped and less weight will be shipped, because everything can be presented locally. For picking, no huge changes anticipated, actually, only when local 3D printing centers or private 3D printing becomes the norm, which is not expected in the future. And here's one from the expert, one statement who said, goods still have to be sorted, packaged, and sent to customers. And I think that summarizes quite well. As long as you still have to move around, picking processes will probably not change. Okay, so as a summary of the results, for research question number 1, we see that 3D printing has the potential to bring production closer to the customer and thus reduce global transportation. However, distribution logistics and transportation processes will still be needed for the delivery of products from the producer to the end customer. For research question number 2, we found out that 3D printing will allow logistic service providers to venture in new business models, such as 3D print centers, 3D print shops, or service pools. And for research question number 3, we can say that 3D printing can optimize the use of warehouses by enabling on-demand printing and thus reducing the need for keeping every part on stock. However, picking and transport processes will not undergo major changes in the near future. As every study, also our study has its limitations. And the main limitation is that it's a qualitative study resulting from the subjective results of the interviewed experts. So it's very subjective overview. Also, we only have a sample size of 9 experts from the German-speaking area, which obviously limits its generalizability. However, I want to point out that we try to minimize these limitations by rigorous expert selection processes and structured analysis approach to ensure a reliable data gathering and analysis. So we really try to select the right experts for the right questions, so to say. And for future research, obviously our research can be expanded. So one could expand the sample size and alter the scope of our study to enhance the generalizability of our findings. And with that, these were the references used in this presentation. In the paper, you will find more references. And yeah, thank you for your attention. If you have any question, please feel free.
Yeah, that's a nice presentation within the time frame. So any questions from the participants? Quick 1 or 2 questions because we have limited time. Please understand we have only 12 minutes. So try to focus more on your contributions rather than spending more time on the introduction. And Robert, you did a good job. So any questions from the participants? No? Shall we proceed to the next presenter?
Okay. Thank you, everyone.
Yeah.
Thank you, Robert. We'll now move on to our next presenter. I would like to request the next presenter, Oscar Yelan Gaza, to present their paper on sentiment analysis about the popular soccer player Mbappe on social media and newspaper. I'll request him to please present his paper.
Okay. Hello, everybody. Okay. I'm a master's student in Tecnológico de Monterrey. Let me share my screen so you can see. Okay.
Yes.
Okay.
Go ahead.
Okay.
Yeah.
Okay. Thanks. Okay. Okay, as I was saying, I am a master's student in computer science, and we decided to do some data analytics about sentiment analysis about the popular soccer player Mbappe on social media and newspapers, right? And okay, the study went as follows. Okay, we decided to do 4 analyses in order to see how Mbappe popularity was affected because of his scandals. The last year, Mbappe had some scandals about Real Madrid not joining this team, and also because he had like some. He had a girlfriend. She was a trans model, and we wanted to see how the media and how the public in general reacted to this news and how affected its popularity. Okay, in order to do this, okay, we did the following. We used some techniques about text classification, text extraction. We basically, okay, I'm going to explain which 4 analyses we did in order to do this study. And well, basically we wanted to see the sentiment analysis about the media and about also the public in general, like the soccer fans, how this football fans, how they feel about this and how it affected the popularity of Mbappe, because last year he was the most popular player, and how this affected his influence. Okay. Well, basically, the methods and data that we did, it was sentiment analysis in mainstream media publication. We decided to choose the top 20 biggest media about sports, and we decided to analyze what do they publish about this news, and to see with some libraries, data analysis, how the sentiment was to these topics. Also, we did that was with some libraries. Then we decided to use also we created a method from scratch where we web scrap the 5 first pages of Google News where they were talking about these topics, and we decided to retrieve the links and retrieve the news, and we make an analysis because we inserted a list of 100 words for negative, neutral, and positive, and we make a frequency analysis of how many times these words were repeated in this news, in these articles. Also, we decided to use the tool of Google Trends in order to see how much was Mbappe talk about this topic during the time frames that we decided to use in order to try to avoid the noise, because also Mbappe was it was a lot also the news about the problem with Neymar, and we didn't wanted to analyze that part, so we also decided to delay that time frame where it was more talk about the Neymar problem than the others too. Okay, and okay, we also analyzed the social network sentiment analysis from comments. How did we do this? We analyzed from Facebook publications of this mainstream media, Marca and another football news and some other big media, how the fans, because we first analyzed, like the media, how they presented, but we also wanted to see how the fans reacted to this. That's why we use this, and we make also a web scrap with the Facebook publications, with the comments, and we analyze also the sentiment analysis about how the fans behave. And we did this study in 2 languages. Well, we are from Mexico, and also because we know that a lot of football fans are from Spanish-speaking countries. So we decided to do the analysis in English and in Spanish for this part. And okay, the results were the following. For example, we had the hypothesis that the English and American media will be more positive with this news because they are more open and more pro LGBTQ rights, and and basically the data confirms that, because as you can see, the positive ones in the first graph, we see that we have that the most positive is Daily Star, that is British, and also Sports Brief. And we saw that the more negative one was Marca, that is a really popular Spanish media. Okay, but we saw that in general it was more neutral, this publication, with a 0.96 coefficient, and we saw that the 0.021 it was for negative, and 0.164 it was for positive score of the titles. Okay, we also decided to do the analysis. In this map, we can see how per states in Mexico, how they talk about this. The most blue ones were the ones that were more negative, and one with the light ones were the most neutral. Okay, we did this analysis, and we used like some, as I told you, some words, and we searched like were negative, positive, and we make this analysis, and we saw the relative frequency. We basically count all the words in this website with web scraping techniques, and we make the frequency, right? And we saw how this affected how they were affected. And well, as I was telling you at the end, we saw that basically also in basically the networks social networks that we saw, also the Spanish comments were more sentimental. In what sense? They were more positive and more negative. They were not neutral, basically. And the English comment, the English fans were more neutral about this topic, and the Spanish ones were more like the people who commented good things about this topic, or they also commented like negative things. So we also have that our hypothesis that the Spanish-speaking people in these topics are more sentimental were right, because at least the data show us that it was not big, like it was more or less 30% in difference, but at least it was still that the Spanish-speaking fans were more sentimental to positive or negative in this sense. And okay, as I was telling you, Spanish and Latin American are more emotional in these topics, so they were more positive and negative. Also, the English media is more positive or neutral in comparison with the Spanish ones. As I told you, like Marca was the only one negative. In reality, the other ones or were neutral or were positive about this. And okay, and also for future work, we will like to make how this affected the market about the price of Mbappe, because Mbappe it had reducing his price when these standards were. So for future work, we would like to make how this affected his market analysis and also his follower analysis in Instagram, because it also seemed reduced obviously he was still growing the amount of followers, but the trend lines it diminished, and that's what we would like to do in future work, how this affected his market and follower analysis.
Yes.
Okay, and thank you.
Yeah, any questions on this?
Sorry,
So,
what?
Yeah, feel free to ask any questions now. Maybe one.
I got a question for Oscar.
Yeah, go ahead. Go ahead.
Hello, Oscar. Thank you for your presentation. Question will be, your model could be applicable to a different soccer player, and what data would you need to provide? And the second question is, what was the most important challenge in doing this project?
Okay, thank you. Okay, yes, basically the only difference that we have to do as we make like some in Jupyter notebooks in order to do this analysis, the only thing that we have to do is, instead of making the search of Mbappe, the scandals, it should be the name of the other football player. It is the only thing that we have to do in difference, because basically that's why we automated everything in order to make the web scrap, just in order to change the name of the player. It's really easy to make this change for us. Yes, in all these studies,
right,
it's just changing the name. And the most challenging part, it was definitely the web scraping part. In some sites, it's like sometimes difficult because of the HTML, that you have to clean the data and all this stuff. And also the social networks analysis, it was kind of hard because we tried to use more than Facebook. We tried to use Twitter, but we needed some APIs that we didn't have. So that was also why we didn't do the analysis in our social networks. And that's why we want to do that as a future work.
Thank you.
Yeah, that's good. You can stop sharing your screen, Oscar.
Yeah.
Yeah, that's a good answer. So I think we can proceed to the next presenter, please, because we are running out of time. So we'll move on to the next presenter.
Thank you, Oscar. We would like to move on to our next presenter now. I would like to request our next presenter, Helena Valencia Ulade, to please present their paper on sentiment analysis of IMDb movie reviews using deep learning techniques. Please go on with your presentation.
Yes.
Thank you. Hello, everyone.
Hello.
Okay, good afternoon. My name is Elena Valencia. I'm a master's student at Tecnológico Monterrey, and today I'm presenting our work, sentiment analysis of IMDb movie reviews using deep learning techniques. Movie reviews help users to evaluate and decide if a certain movie is of the particular interest, depending on the positive and negative comments made by other users. However, analyzing them can be a tedious process. So in this work, we use sentiment analysis as a method to understand these short texts and to derive meaningful insights from them. Sentiment analysis can be considered as a classification process that can be divided into 5 steps. First, we have data collection, which can come from content for blogs, forums, social networks, and this data is commonly unstructured, expressed in different ways and with different vocabularies and contexts. The next step is text preparation, which consists in cleaning the extract data before analyzing it. The next step, we remove irrelevant information and non-textual contents. Then we proceed to the other step involves the sentiment detection by the examination of the extract sentences of the reviews and opinions. The step 4 involves the classification of the sentiment, which could be classified into positive and negative reviews, and even good, bad, like, dislike, and so on. The final step is the presentation of the output graphically for proper interpretation. Recently, transformers have been introduced as a new method to perform NLP tasks with better results than previous approaches. So basically, a transformer is a deep learning model that is self-sufficient and that can evaluate its input and output data representation. By using transfer learning with transformer languages models, these pre-trained models can be shared and then be fine-tuned depending on the specific task it will be assigned. This eliminates the need of training a neural network from scratch, so you can focus on fine-tuning for your application. Some of the most famous models include Megatron, GPT-2, XLNet, BERT. However, for this work, we will be focusing on testing 3, which are BERT, Roberta, and LXNet for the sentiment analysis task. So here we present some general information about each of the models. First, we have the BERT model, which consists of a series of bidirectional multilayer encoder based transformers. This model takes a whole input sequence altogether and uses mass language model and next sentence prediction as pre-training strategies. It is capable of understanding long-term dependencies and can be fine-tuned for faster training times. Next, we have Roberta, which removes the next sentence pre-training objective and trains in much larger mini batches. Also, Roberta removes the NSP loss present in BERT and also in contrast to BERT, which use a static masking. Roberta use a dynamic masking where different parts of the sentence are masked in each epoch. This makes the model more robust. Finally, we have XLNet, which combines the strengths of autoregressive language modeling and autoencoding, and it also enables learning bidirectional context and has shown lower error rates than BERT in sentiment analysis tasks. So we expect a better performance using this model. In this work, we are also working with topic identification in both negative and positive movie reviews. For this task, we employ TF-IDF and k-means clustering. TF-IDF is a combination of 2 different terms where term frequency allows to quantify the number of times a term is present in a document. Then the inverse document frequency allows to identify the level of importance for the keywords. Lower weight is assigned to words that appear more frequently and higher weights to those that appear less frequently. We also use k-means clustering as a way of identifying the main topics that were talked about in both positive and negative reviews. In order to define the number of clusters, we employ some performance indicators like the elbow method and the silhouette score. In the next slides, we'll talk about how these models were applied. So the database we used for this project was the IMDb dataset that contains 50K movie reviews classified as positive or negative reviews. Before implementing any text analysis or deep learning algorithm, we performed the corresponding data preprocessing and exploratory analysis of our dataset. It was found that the dataset contained 418 duplicates reviewed, so we decided to remove them. Therefore, we were left with around 49.5K reviews. And then we proceed to clean the data by removing stopwords and converting the target variable to a binary classification, as we can see in the figure of the data frame. We also explored the ratio between the positive and negative reviews, and it was found that the dataset is balanced, making it adequate for training and testing. We create 2 word clouds of both positive and negative reviews in order to have a visual overview of the most frequently used words in each type of review. As we can see, individual words don't give much information about the sentiment, since it will depend on the whole context in which these words are used. However, we can observe the most frequent words are expected for this data set, which are film, movie, story, character, time, among others. As mentioned in the previous slide, the most common words in both positive and negative reviews include words like movie, film, wine, among others. We decide to eliminate them since these words don't provide any information. Additionally, we're performing K-mean clustering analysis in order to identify the main topics that are discussed in positive and negative reviews separately. In order to do this, we also decide to eliminate other words like people, watch, worse, bad, horrible, terrible, awful, good, with among others, because they are either not relevant or are directly related to the sentiment and do not provide useful information for the cluster analysis, which is performed separately for both positive and negative reviews. The elimination of this word allows to have more representation clusters that give some insights regarding the specific topics and not the sentiment per se discussed in the reviews. We apply TF, IDF, and K-means to perform the text clustering to a sample of our data. We select a random sample of 5K reviews for each positive and negative group, since these algorithms are computationally expensive to perform to all our data set. To determine the optical number of clusters for our data set, we decide to use both elbow method and silhouette scores. For the first method, we plot the values of the cost function produced by different values of K from 4 to 12. As it can be seen in figures on the right, the value of K at which improvement in distortion declines was achieved with a K equals 8 with positive and negative reviews. Finally, to verify that our number cluster was optimal, we decided to run several experiments changing the value of K from 6 to 9 and compare its silhouette coefficient. Table 2 and Table 3 shows the result obtained from different experiments for both positive and negative reviews. After analyzing the results, we can confirm that the optimal K is 8 for both reviews, since the highest silhouette coefficient was obtained with this number in both cases. Here we have the clusters generated for positive reviews. We can see, for example, like cluster 0 includes more words like music, dance, song, band, which implies a topic related with movies in the genre of musicals or movie involving dancing and singing. Cluster 1 includes words like character, play, performance, actor, role, which implies that these reviews focus on a positive view of the acting performance in the movies. Cluster 2 includes topics related to a series and family-related content. Cluster 3 includes games and action. And finally, cluster 4 includes words for horror movies and effects and so on. In this slide, we have the word class for some of the clusters that provide the most insights for us. Again, cluster 0 was related with music, dancing, cluster 1 with the acting performance of the characters in the movie, and cluster 4 regarding horror movies, effects, and budget. This could indicate that these types of movies were well received by the public. Now we are going to show the results for the negative reviews. For instance, in cluster 0, we can find words like horror, kill, killer, monster, slasher, which could indicate that this cluster includes topics related to negative use of horror movies, focusing on slashers and monsters. Cluster 1 include words like book, read, version, change, adapt, which implies that other common topic in negative reviews was related to movies based on book adaptations. Cluster 3 was related to comedies, humor, cluster 5 to action movies, and cluster 6 to horror movies, but with a different perspective, or the main focus was zombies and vampires. Here we can see the word clouds for negative reviews. One of the most interesting ones was cluster 1, since it talked about movies from book adaptations. As we know, it is common for movies based on books to be criticized by the audience, so this cluster highlights it. Negative reviews focus also on topics related to horror movies, as seen in cluster 6, but mainly for movies related to zombie and vampires, which might imply that this type of movies were not well received by the public. Additionally, there was also plenty of criticisms related to comedy movies, thus it could imply that the type of humor used was not well received. So as we can see, this analysis provides a deeper insight from movies reviews than just the sentiment classifications into positive and negative results. So one of the main objectives of this research project was also to apply transfer-based language models and compare the performance. We decided to use 10K reviews to train each of the model and 500 reviews for testing. Here we show the results we obtained. We use accuracy and F1 score as our evaluation metrics. As we can see, the model that achieved the highest performance was the ExcelNet with an overall accuracy of 0.90 and a F1 score for negative of 0.89 and a F1 score for positive of 0.91. Roberta also obtained similar results, however, it had a lower F1 score for positive reviews. Finally, Bert had 2% lower values for all the metrics. In the next slide, we are showing the confusion metrics. As it can be seen, the model performed better at predicting positive reviews than negative reviews, and it outperformed all the other models. So our conclusions are that TF-IDF is a tool that, in contrast to other methods like back of words, provides information on the more important words in the document by providing a weighted representation. K-mean clusterings provide useful insights regarding the main topics talked about in both positive and negative reviews. And finally, ExcelNet was confirmed to outperform BERT for this particular sentiment analysis task. That's it. Thank you very much.
Nice. So any questions, any quick questions, please? Just we can take one or two.
I have one questions for Helena. Hello, Helena. Thank you for your presentation. The question is, were you surprised by the results you obtained? And what was the most important challenge in doing this project?
Okay, so yeah, we were really surprised by the results we obtained, mainly on the TF-IDF and K-mean clusters, because we didn't have, like, for example, label data because it's an unsupervised learning. So we were really surprised when we found that the K-mean model was really accurate at grouping this type of reviews. For example, we show the clusters and we read some of the examples that, for example, for cluster 0, we show that we see that the reviews were actually of the topic that we talk about. So yeah, and I think one of the most important challenge was the cleaning part, also with the TF-IDF and K-mean clusters, because we had a lot of words that were not providing really important information and insight. So we were deciding which words were important and which we'll have to eliminate. And yeah, I think that was the most challenging part.
Thank you very much. Thank you.
Yep, you can drop your screen, Helena. I think we can move on to the next presenter. Please note of the time. You have exactly 12 minutes and 3 minutes for questions, please.
Thank you,
Helena.
Yeah. We would like to move on to our next presenter, Adrian Peralta. They'll be presenting their paper on technological solutions for collecting, analyzing, and visualizing traffic accidents, a mapping review. Please continue with your paper, Adrian.
Hi. Okay, wait a minute.
Hello. Yeah.
Okay. Hello, good afternoon to everyone. My name is Adrian Peralta. I'm a master's student from the Autonomous University of Baja California, Mexico. And on behalf of my co-authors, Hector Sataraina Cebes and Karina Caro, I will present the work entitled Technological Solution for Collecting, Analyzing, and Visualizing Traffic Accident and Mapping Review. Without further inconvenience, I will start my presentation. The World Health Organization establishes that approximately 1.3 million lives are lost from traffic accidents worldwide. Between 20 and 50 million people suffer injuries that sometimes cause some disability to the people involved. Therefore, this cause of accident has become a significant worldwide health problem. Injuries induced by traffic accident cause significant economic losses for the people involved and the country where the accident occurs, costing about 3% of the gross domestic product. Uh, Delayed pre-hospital care for traffic accident increase the severity of the injuries. Sometimes these injuries can have a high impact on the person and within minutes can cause death if they are not treated on time. In Mexico, during the year 2020, traffic accident occupied the ninth cause of death. Therefore, the Technical Secretariat of the National Council for Accident Prevention aims to create and implement strategies and action to reduce morbidity and mortality by injuries caused by accident. Organizations such as the Ministry of the Health and the State Attorney General Office want to identify behavior patterns that allow them to reduce and act promptly in the face of these incidents. Most of the traffic accident data collected in Mexico are stored only on databases. Unfortunately, these data are not analyzed or visualized. This data is simply stored without being used for the future analysis. Additionally, each Mexican instances has its collecting system, which is a problem since data duplication, loss, and erroneous captures sometimes occurs. On the other hand, several main factors cause a traffic accident have been identified. For example, driver drives while intoxicated, driving speeding, doesn't have a seatbelt, or use the cell phone. For infrastructure is not in a good condition or there are no signs. And finally, transport vehicle does not have a corresponding services. The government of each country must adopt measures to reduce and prevent traffic accidents. For this is necessary to work together with different sectors such as the health, education, transport, security sectors. It also important to identify what technologies exist and can help reduce and prevent traffic accidents. In this sense, this paper presents a mapping review that investigates the technological solution in the literature regarding traffic accident data collection, analysis, and visualization. We conduct a mapping review in 3 phases. And the first phase is planning. In this phase, we define the research question, define the keywords. We can see in the table 1 different keywords. For example, technology, system, big data, data mining, machine learning, analysis, dashboard, accident prediction, and traffic accident. Define the search query, define the search engines, and define inclusion and exclusion criteria. The second phase is its execution, and this phase sort articles by relevance, conduct the selection by title from the first 200 results of each database, conduct the selection by abstract, analysis by result and conclusion, and finally, the third phase is reporting. And this phase describes and discusses the obtained results, answering each research question, defined in the planning stage. These figures show the result obtained for the mapping review. In total, we obtained 653 registers after removing duplicate. Then we obtained a total 255 excluding works by title and abstract. After that, we obtained 19 registers excluding by conclusion and results. And finally, we include only 44 registers after complete the reading. And this table presents classification of the articles according to the research question. For the case of the research question 1, what technologies or tools have been used for to collecting, analyzing, and visualizing traffic accident data? We found 3 main technologies: big data, data mining, and machine learning. For example, a paper classified in the big data section is this work of Abdullah and Iman in 2016, where they present an application that uses big data tools to store, integrate, and analyze traffic accidents. They used a data set of traffic collision in New York City to develop the application, which includes several data features such as the common cause of accident by district, the street where the accident occurred, and the number of fatalities, among others. It also provides a web service to analyze and visualize information on major traffic accidents. For the case of the research at the question 4, what are collecting, analysis, and visualization system for the traffic accident data in Mexico? We found only 3 articles. For example, the work of Trujillo Alvarez, and Maldonado. The authors analyzed the problem faced by the Tijuana, Baja California Red Cross unit concerning the ambulance service and pre-hospital care. Currently, the number of the ambulance operating in Tijuana cannot cover the entire city, which generate delays in the time to go to the emergency and provide medical care services. And this work aims to compare and generate strategies using different optimization models to improve the service of Red Cross units, reducing response time and increasing the coverage. As a conclusion, this paper presents a mapping review on collecting, analyzing, and visualizing traffic accident data. The results include 44 articles aimed at answering for research questions. Only 3 articles were found related to traffic accident data in Mexico and uncovering an area of opportunity for researchers. These are some of the references used in this work. You can find the complete list in the paper. And thank you for your time. Here's my email address in case you have a question or you want to contact me. Thank you.
Yeah, good job, Adrian. So, any questions quickly? Yeah, good. I think we can move on to the next presenter, please.
Okay.
Thank you so much, Adrian. We would like to move on to our next presenter. I would like to request Gabriela Mendoza to please present her paper on the respective paper title, Time Series Analysis of Public Opinion on Work from Home during after COVID-19 pandemic.
Yes, thank you. I will be presenting alongside my partner, Jorge Arturo Mendez.
Okay, we are Gabriela Mendoza and Arturo Mendez. We realize this project as master students at Tecnológico de Monterrey, and our project is a time series analysis of public opinion on work from home during and after the COVID-19 pandemic. Time series analysis, or TSA, is a method focused on analyzing data points that were collected over a period of time. TSA encompasses several methods and models, and it can also be used to create prediction models that are able to forecast data based on the input historical data. In this project, we will make use of the autoregressive integrated moving average ARIMA model, which is fitted to the time series to be able to better understand the data and predict future data points. This project aims to study data collected by Aman Kumar, in which the increase in residential stay was recorded by date in several countries starting from February 17, 2020 up to January 30, 2022. And the data was downloaded from Kaggle. Understanding and predicting this data will give us a glimpse on the preferences of people regarding remote and on-site jobs, and this will be beneficial knowledge to businesses going forward, especially after the pandemic. We began with the exploration of these data values and understanding what can be obtained from them. One of the first things to note were the 3 main data columns: entity, that's the country; the day, that's the time; and the increase in residential stay. There were a total of 91,933 rows. And when analyzing the data, it was also noticed that almost all countries had a total of 714 rows, with the exception of a few that had less. We decided to drop these countries with less rows to obtain a more comparable data set. Also, to be able to do a clustering analysis, it was necessary to modify the data frame to a way in which each column represented a different country and had its corresponding time series. Continuing with the data exploration, a plot comparing all time series was created. It can be noted from the plot of all time series that most countries show a similar tendency in the increase in residential stay variable, with a few exceptions, which will be the lines that deviate from the denser parts of the graph. This can be further compared with government restrictions regarding work from home, and a pattern could be found. And with this, the exploration of the data was concluded and the experimentation phase began. And moving on to the experimentation phase of the project, this was divided into two different procedures. First, a cluster analysis on all data, including all countries, and then focusing especially on Mexico and trying to forecast using the ARIMA model. A hierarchical clustering was constructed with several variations to the methods. First, using the WARD method, and then using the single method using Spearman and Pearson correlations. We can visualize how both the Spearman and Pearson correlation clusters did not turn out so well, especially compared to the clusters obtained by using the WARD method, which are very identifiable. And both the Spearman and Pearson correlation clusters turn out very differently compared to those of the WARD method. And this cluster analysis will be useful, for example, in understanding how different countries share similar behaviors, why they are clustered together, and find out if this means they will also maintain this behavioral similarity in the future.
Okay, so as my partner mentioned, we decided to focus our project on the prediction of Mexico's residential stay using ARIMA. To begin, we had to make sure that the data was stationary to be able to analyze and predict it. For this, we conducted a Dickey-Fuller test, but even when this test resulted in the rejection of the null hypothesis, meaning the time series was stationary, after graphing the time series, the data did not show convincing stationarity, and we decided to improve it by obtaining the logarithm of the data and a shift of 10 to make sure no values were negative. A second Dickey-Fuller test was conducted, and it concluded that this time series was stationary. The pattern of the trend and seasonality can be seen on the two graphs on the center. After this, we ran the autocorrelation functions to obtain the correct logograms and find the best AR and MA parameter combinations to obtain the best predictions. These were 1 to 1. This figure shows how well the model was able to describe the original data. Nevertheless, when we tried to train the model with the original data minus 35 days to be able to compare them and actually predict values that hadn't been given to it, the prediction turned out as a straight line, shown in green. We tried many other parameters, and when they all turned out the same, we figured out it was caused by the data input. To solve this, we decided that instead we should use the rolling mean of the logarithm of the data. Once again, we ran the autocorrelation functions, and the parameters to be selected were to be 1, 3, 1. But the D parameter could not be greater than 2, and therefore we selected 1, 2, 1. Nevertheless, this prediction also turned out to be a straight line, and therefore we decided to vary the parameters within a certain range, and after trying several combinations, such as 313 and 414, we decided on this last one due to it having the lowest AIC and BIC values, which are a way of measuring model performance that also account for model complexity. What we observed was that this model had the best accuracy in predicting the values not included in the training, and that its long-term prediction showed a tendency over time for the predicted values to stay constant. It's possible, therefore, our conclusions were that it's possible to assume that the tendency over time will stay constant, meaning there will be, in average, a constant increase of people who will desire to work from home. Nevertheless, these results were not definitive, considering the tendency shown on this figure, which even if it did not show the lowest AIC and BIC values for parameters 313, this graph shows a tendency to decline over time with a few oscillations. Another observation that was noted on a few of the predictions was a small bump around the month of June, meaning an increase in the number of people who desire to work from home. And this could be partly attributed to people who, for example, have children and wish to stay home for their summer school vacations. General conclusions include how data input and ARIMA parameters affect the predictions. In this case, we found out that exploring the data to extract representative parameters without losing information, such as using the rolling mean in this case, might prove to be useful to predict more suitable results. Also, the p-parameter values should be chosen wisely, since it was observed how even a small change could transform a linear prediction into a prediction that showed change over time. Finally, our recommendation was that even with autocorrelation functions and autorima, it would be good to test other parameter combinations, and that to have the best result predictions, to keep updating the data as to also maintain a good confidence interval. For the future of this project, it would be interesting to answer research questions on whether the increase or decrease in the percentage observed is related to the pandemic, or if it's something that happens constantly each year. This could be done with more data records. Other propositions include predictions on other countries and comparison between them, so as to answer the questions, is there a similarity between Mexico and the US, or between Mexico and other Latin American countries, or even Mexico and other countries on the same cluster? And with more investigative research and a more complete data set, answer the question of are the peaks shown on the current data values due to government policies, or was personal preference also a factor? That's it. Thank you for your attention.
Nice, nice, thank you. So any quick questions? We can take one or two.
Yes, I have a question for Arturo. Thank you for Arturo and for Gabby. Thank you for your presentation. So the question is, the results that you obtained were kind of expected, or were you surprised with the results? And what was the main challenge in doing this project?
Well, I think I was expecting something like this, and I was a little bit surprised that the best one was actually the one with parameter 414. So instead of a decrease on the people wanting to stay at home, it actually stayed kind of constant. So it's a constant increase, which after thinking about it, kind of also makes sense, because after the pandemic, more and more people are wanting to work from home. I can say that for myself, at least, for example. So yes, I think I'd say it's a little bit surprised, but not that surprised. I don't know if Arturo wants to answer the second question.
Well, we think that our biggest challenge was when creating the prediction, when we obtained a straight line with several ARIMA parameters. We didn't know exactly why that was happening, so we had to try different parameters in order to get a better prediction, and we believe that was our challenge, our greatest challenge.
Okay, thank you, Gabby, Arturo. Thank you.
Good job. So Anjali, we can move on to the next presenter. You're on mute, Anjali.
Sure, sir. Thank you so much, Gabriela. We would like to move on to our next presenter. I would like to request Log and Limon to present their paper on towards prototyping single model and multi-model interactions in mixed reality games.
Hello, let me share my screen.
Yeah, go ahead.
Yes, the screen is visible. You can continue.
Okay, so my name is Logan Lamont, and today I will be presenting on prototyping single modal and multimodal interactions in mixed reality games. So mixed reality provides a new way to interact with games and gives users a new level of immersion by kind of blending the physical world with the digital world. And from analysis of past studies and related work, we learned that the mixed reality environment has expanded into other domains such as healthcare, education, and engineering. However, there is not much research done in the game design world due to the fact of just inherent issues such as field of view in headsets, lack of system resources and computational power, and also some physical discomforts with mixed reality technology. So our main goal of this research project is to explore the application of mixed reality technology in the field of games, and also to illustrate the prototyping process involved in developing games for the MR environment. So for mixed reality and its challenges, mixed reality is the blending of the physical and the digital world, and it's kind of like the next step in spatial computing. And so one of the mixed reality headsets is the Microsoft HoloLens 2, which was released in 2019, and that's what we will be using for our study. And we use the HoloLens 2 because it has many different functions, such as the ability to take in voice commands, recognize gestures, and it also has a depth camera for spatial map surroundings. But even this headset does have its limitations. It has a 54-degree field of view. It also has to have specific lighting conditions in order to work. And there's some physical discomfort with it too, especially for first-time users with the weight of the headset. It can be kind of, you can cause some neck strain. And at the moment, there's limited hardware capabilities, which kind of makes it difficult to render complex 3D video game scenes. But we will work around these challenges and try to create the best games that we can and focus on interactions. So for our research goals, we aim to explore the interaction modalities in HoloLens 2 and to prototype multiple games that are playable in the MR environment using different forms of interactions. We want to find out what games can be played using different inputs and which inputs contribute toward better user experience in the MR environment. And so today we'll be focusing on the prototyping process involved in developing 5 MR games using single modal and multimodal interaction systems. So we created 5 total games. 2 of the games are speech-based, 1 is gaze-based, 1 is gesture, and then 1 is multimodal, which combines all 3. And we created these games using the Unity game engine and also mixed reality toolkit. So for the design and development process, we selected 3 interaction modalities, gesture, gaze, and speech, and developed games around them. In addition to the interaction modalities, we considered limitations such as field of view, graphics, physical discomfort, what I was mentioning before. And for the graphics, we used lower poly assets for seamless rendering, and also to reduce the application size on the Microsoft HoloLens 2. And to ensure comfort, we decided to keep all the games under 6 minutes long, so there isn't that much physical discomfort or neck strain, especially for first-time users. And so this assumption was based on our initial prototyping, which we did through body storming. And body storming is the act of using physical objects to simulate what the product would look like if it actually existed. And this was our first stage in the prototyping process, because it gives you, body storming typically gives you insight into the player's point of view because it simulates what the product will actually do in the real world. And body storming is also very simple because you can use cheap arts and crafts to rapidly prototype elements needed for the experience. And so for this process, we built a mock-up of an MR headset out of straws so we can have an idea what the viewport will look like. And so during the body storming process, we role-played certain game mechanics and interactions that we were kind of brainstorming at the time in order to fully understand how players will be moving around the space and interacting with elements in our MR games. Specifically, we role-played picking up objects, gazing at objects, and kind of just walking around using the mock-up headset. This experience helped us a lot in smoothly transitioning to development because we were able to set certain goals for what we wanted the mechanics to act like and how we wanted the games to be designed. So for the prototype development, our first prototype was a gaze-based game. So this is a single modal interaction game because it only uses one interaction, which is gaze. And so in this prototype, we developed a alien tower defense style game. In this game, the user gazes in order to defend their home base from aliens. The game consists of 3 towers, and the goal of the player is to defend the towers from the aliens. There are 2 levels, each have an 80-second timer. Level 1 consists of aliens constantly spawning all around the player and going after a random tower, and level 2 kind of ups the difficulty by spawning in some more friendly enemies that you are not supposed to destroy. And during the body storming process, we learned that making users frequently move their heads can cause some neck strain. And so to mitigate this, we slowed down the speed of all the moving objects in the scene. And we also made sure that all 3 towers were right around eye level. For our second prototype, we developed a speech-based game, again, single modal, and this was a word search style of game. And so we developed a speech-based word search game where players try to find as many words as possible in a 4x4 or 5x5 grid of letters. And there are 4 total levels throughout this game. 2 are 4x4 grids and the other 2 levels are 5x5 grids. And there will be a 5-minute timer that continuously runs through, and you try to just get as many words as you possibly can. If you get through all 4 levels within the time, you win the game. If you're not, then you lose, but you still are able to see your score, so maybe you can improve or compete with other people. From the body storing process, we learned that having the word search grids around 4 meters away from the user is kind of an ideal position. It's kind of like the sweet spot for a lot of the UI in mixed reality, because you don't have to move your head that much to see everything, and you can kind of just read everything clearly. For our third prototype, this is our second-based speech game, again, single modal, and we developed a rock, paper, scissors style of game. And so the reason we created 2 speech-based games was because during our initial trial runs of our previous prototype, the word search game, we realized that the gameplay time was kind of going a little bit longer than expected. And so we just decided to kind of go to a different style of game to just be a little bit quicker and to have more spontaneous speech-based mechanics. And so in this prototype, the user will play against the computer. They will provide voice commands for whatever move they want, either rock, paper, or scissors, and the game will determine who wins. From the body storing process, we learned that there needs to be adequate time for the user to put in their input, and then for the computer to show their move, and then for the winner to be determined. And so we didn't want anything to feel rushed to the point of confusion. So for our fourth prototype, this is again a single modal game. This is our gesture-based game, and it's a job simulator style of game. And the goal of the player is to shut down hazards and collect objects in order to replace their spaceship, or repair their spaceship. In this game, players will be trapped in space with a broken spaceship, and they need to avoid the dangers of outer space in order to get back home. Players will face 3 levels with increasing difficulty, and they need to collect a bunch of different objects around the scene, all into one bin. And then once they complete all 3 levels, and their spaceship is repaired, and they win the game. And so in this prototype, we incorporated gestures in HoloLens 2, such as air tap, pinch, distance grab, and stop sign. And from the body storing process, we learned that we had a lot of freedom in terms of where to put objects, since the users would actively be moving around the room while playing this game. And so we were really able to take a lot of advantage with the freedom of MR. And for our 5th and final prototype, this is our multimodal interactions game. And this is a Dragon Slayer style of game where the user will go up against a dragon, and they have to kill a bunch of different minions around the scene using voice commands for spells, and using their gaze for aim, and then also using gestures in order to fire their spells. And then they will use gestures to pick up a sword that gets charged up through killing enemies in order to hit the dragon and eventually kill the dragon. And so from the body storing process for this game, we learned that we could utilize the entire area again as well in this one, since the user will be moving around the room. And initially we tried to use real life objects such as chairs in order to provide cover from the dragon's fire breath. But the mixed reality headset had a little bit of trouble sometimes picking up those real life objects. So we just decided to use holograms in our video game scenes instead to provide cover for the user. And so in conclusion, I presented the process of prototyping and developing 5 MR games, and specifically our prototypes were focused on using single modal and multimodal interaction modalities in the mixed reality environment. I believe that the findings from this work can contribute to ongoing research in experience design and immersive technologies and games research in mixed reality. And so here are some of the main learning points from this experience. So during the development process in this project, we noticed that deployment time is very time consuming. It could take roughly 10 minutes even for any minor change just to see what your change actually did. And so there's a lot of time that goes into that. And then we also found that using low poly assets can improve game optimization and rendering, and it prevents things such as lag. And so also having around 3 to 4 meters of play space is kind of the sweet spot for a lot of the spatial mapping in the mixed reality environment. And lastly, using prototyping techniques such as body storming was a big help in identifying project requirements and gathering insights on interactions, spatial constraints, and player comfort aspects. And so for future work, we plan to conduct user studies with these 5 MR games, where we will incorporate an EEG device to capture brain activity of the users while they play their games. And from that EEG data, we will analyze the user emotions and experiences associated with gameplay. And in addition to user emotions, we'll also conduct a comparative analysis between single modal and multimodal mixed reality games in order to understand the impact of each interaction modality on the gameplay. And that's it. Thank you.
Good. Any quick question? Okay, you can drop your screen. Great.
Thank you so much, Logan. As we are done with all the presentations, I would like to move on to the closing remarks. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7 versions of the conference. We'll be happy to have you in the 9th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publications will be live within 6 months. So I would request you all to kindly cooperate with the team of ICICT 2023. I would also like to thank our session chair, Professor James Stephen, for chairing the session. Here's a token of appreciation on behalf of ICICT 2023 and Global Knowledge Research Foundation and partners. Thank you so much, sir. Thank you so much for your valuable presence.
Thank you.
I would like to request all of you to please turn on your cameras for a quick snapshot of the virtual conference. I'll be obliged if you all can turn on your cameras so that we can have a quick snapshot. Thank you so much. Thank you so much, everyone. Please take care and stay safe. Thank you.
Thank you.
Thank you.
Thank you.
Bye.
Thank you. Bye.